today is shielded metal arc welding and gas metal arc welding. First thing I want to show you is where the welding equipment is kept, safety equipment. In this cabinet is the helmets, welding helmets. Some of them have flip-up type of shields, and they should have a plexiglass shield on the inside as well. If your particular shield is very fogged over, come and see me. We can get you a new lens possibly. Then you just want to adjust the helmet to your head size. It should be adjustable. Next door is the welding gloves and flame retardant jackets that you should wear, especially if you have some polyester type clothing on. Polyester is flammable and will burn a hole when the sparks hit your shirt and start you on fire. There should be a right and left glove for everyone. One thing I want to tell you about gloves is don't use these to pick up hot objects. The reason why these gloves are fairly stiff and hard to use is because people are picking up their piece they just welded and it's sitting there smoking in their hands. And so gloves are not for picking up hot objects, they're actually for preventing yourself from getting burned. Okay? So pick it up with your pliers in your booth, take it over and cool it down before touching it with your gloves. This right here is the electrode stabilizing oven. It's basically going to keep moisture away from the coating of the electrode. And what an electrode is, this is for shielded metal arc welding, which is the first process you'll be doing. The electrode is a piece of steel wire with a coating on the outside of it, and this coating is made out of the material that will burn in oxygen and remove the oxygen from the area. So the idea is that you're shielding the metal that you're welding by the burning of this coating. Okay, so it's very important that this coating is actually on here and dried out. So if you have some electrodes that have been sitting out and it's humid out, you don't want to use those. You want to put them in here and let them warm up for a couple of days to burn off the moisture. There's two different types of main types of electrodes that we have in here. You can see their label is slightly different. The blue says 6011, and this darker one here says 6013. Okay, we're going to be using the 6013 electrode, so don't use the 6011 electrode. This one will burn right through your workpiece. It's a little easier to use 6013 electrodes. It penetrates less deep into your material. Okay, so when you first start out, when you're first learning, there is some stubs in here that you can take. There's some 6013 stubs in order to practice before you use a full electrode. Okay, otherwise you're going to waste electrodes. So start practicing. It's a lot easier to learn how to use with a shorter electrode because it's easier to move it and manipulate it around. Okay, the sample that you'll be using is a piece of 1/8 inch thick steel. This is low carbon steel, and it's hot rolled. That's why it has this kind of gray texture to it. So it's got a thin layer of iron oxide on the surface. Okay, if we were to take and grind on this a little bit, we would see that it would be shiny underneath this. Okay, so this is the cheaper type of steel that you can buy from whatever, Steel Mart or whatever. Okay, what we're going to be doing is we're actually going to be welding lines on here, and these lines, these actual beads that we're going to be producing, are going to overlap each other. So we make a continuous plate of weld material. Okay, and we'll show you how that works in a little bit. Okay, this particular unit does both shielded metal arc welding and gas tungsten arc welding, otherwise known as TIG. And we're only going to be using it in the shielded metal arc welding mode, where we're going to be using an electrode holder that will hold this electrode and pass current through the electrode. Okay? Now, whether the current is going, remember that electrons are negatively charged, so whether they're flowing through this electrode down to the workpiece or up from the workpiece makes a difference. Okay? We actually want the electrons to be traveling from the workpiece to the electrode. Okay? That means that the workpiece is negative and the electrode is positive. So we're going to be welding in the electrode positive mode, where the electrons are jumping from the workpiece and going to the electrode. In order to set this machine so that it's an electrode positive, okay, there's a lot of buttons and dials on this. This switch right here controls whether we're in alternating current, electrode positive, or electrode negative. Okay? Right now it's in the alternating current mode, so we're going to want to switch this to electrode positive. Make sure the power is off. We want to make sure the power is off, otherwise it can cause damage to the machine. Okay, electrode positive, and then this is a fairly complex machine, so I'm going to show you how this should be set up for what you're doing, and then you just have to make sure to take some notes and to duplicate this. Okay. This is arc control here. This is something that you're not going to be using. You can turn that off. High frequency start should be turned to off. Okay. This output or the contactor, this needs to be in the on position. Okay. A remote would be a foot pedal or some sort of other switch to turn the machine on. So we want this in the on position. That means that your electrode will always be hot. Whenever you touch it to the workpiece, you'll get an arc. You need to be aware of that, otherwise you're going to blind yourself when you don't have your welding helmet on. Okay? Amperage control, we're going to put that on the panel so that we can adjust it here. The amperage we want to be about 100 amps to start out with. So turn your amperage, see amperage adjustment, turn that to 100 amps. That's the current that's going to be passing through the electrode. And the crater time, we want to turn that off. This is something we're not going to be using. Okay? That should be everything that you need to know about this particular unit, how to set it up for shielded metal arc welding. When you're ready to weld, you'll turn the switch on. Okay, this is a solid state inverter welder that we have that is slightly different than the other machines, but it also can do shielded metal arc welding. You'll have to look down near the ground in order to see this, because this will be in the booth actually when you're welding. The most important switch on here is the top switch, which changes between constant voltage and constant current. This process is a constant current process. That's something you might want to remember for later. What I mean by constant current is that the actual amount, you're setting the amperage, the number of electrons that are actually traveling through the workpiece. The voltage is going to vary in order to keep that amperage constant. So we want to be in constant current. The other way you can know on this, if you look at it, it looks like the electrode holder that you're going to be using. Okay? That's the most important switch on this one. Next thing we want to do is make sure that this switch here, which turns it to the remote or onto the panel, we want to be able to switch our amperage right here on the panel. So we want to turn that to panel. And the contactor, or the output, we want to have that on at all times, like in the last case. So in other words, this one as well, if you touch the electrode to the workpiece, you're going to have an arc. Okay? And we're going to turn this to 100 amps, okay, or approximately 100 amps. This particular inductance, we can turn that to about 50%. We're not going to be playing with that too much. Okay, now this particular unit, we don't have a switch in order to change the polarity. The only way to change the polarity is to actually unplug one of the leads and then plug it in the opposite plug. Okay, so we'd switch these two leads around. What we need to do is make sure that the positive lead leads to the electrode holder that we're going to be using. So you want to make sure that you follow this to the end and make sure that it is actually attached to the electrode holder, which looks like this. Okay, so this should be attached to the electrode positive. Okay? So that is the solid state unit that we have. And we have one other type of welder. We'll discuss that next. Okay, these older units, actually, instead of having the amperage read directly, they're a percentage of the setting that you have on this here switch. Okay, if you can see, we're doing direct current. Okay, so we're in the 40 to 190 amp range. This is a percentage of that range. Okay, approximately 70, between 60 and 70 is 100 amps on this particular machine. So you want to set it somewhere between 60 and 70%. Okay, so this lever should be in the 40 to 190 amps mode, and then also reverse polarity or electrode positive. You see a positive sign there. The old lingo for electrode positive was called reverse polarity. Okay. Now these switches down here, we want it to be the remote has to be off, in the off position for this particular unit. The contactor, the remote contactor, we want it to be off. So in other words, we want it to be on all the time. This is kind of confusing, but on this particular machine, we want these both to be off, as well as the high frequency to be off. Okay, and then this post flow time is unimportant. We're not going to be using that. And here's the on switch right here. Okay, I have all my safety gear on. I'm ready to weld. One thing you want to be aware of is that if you have cuffed pants, the sparks could fall on the cuffs and therefore make your pants start on fire. Okay, we've had several incidences of that in the past. So try not to wear pants with cuffs. And if you have a problem with it, we actually have some things you can put around your ankles that will keep the sparks off your ankles. They're like so they call them spats. They go around the bottom of your leg. Okay, what we have here is we have our electrode. We're holding our electrode in the electrode holder, which has a couple little grooves inside. It's a clamp, basically, with a couple grooves. Okay, and you can put it in here. If you look at the grooves, you can put it in there several different ways. Zoom in on that. See that? Yep. Okay, we want to put it in so that we're straight ahead. Okay, 90 degrees to the electrode holder. Okay. You also want to put this in here so that when you hang your electrode holder up, that you're not touching the wall. Okay. If you put it in the opposite way, you're going to end up touching over here. Okay, so you want to make sure that you can hang it up and it won't interfere. Now the other thing that you should have in your booth is a set of pliers right here in your holder. Okay, so your workpiece should be manipulated with these pliers. You have to flip it over or pick it up at any time. Use the pliers, not the gloves. Okay. Always put your pliers back up here. If you leave your pliers next to where you're welding, okay, you see all the spatter, all the little weld nuggets on this grate here. They're going to end up on your pliers and they won't work anymore. So make sure you don't leave them sitting out while you weld. Okay, now what's important for welding is that you have a circuit. In order to make a circuit, you have to have the ground and the electrode. Okay, so this ground needs to be affixed to the actual welding grate. You don't want to fix it to the table because there might not be good contact between the table and the grate. So fix your ground right to the grate for welding. Okay. Okay. The machine is not on right now, so if I touch the electrode to the workpiece, I'm not going to get an arc. If the machine is on, I just blinded myself and whoever else was standing around you, possibly me, and that will not make me happy. So don't do that. Okay. In order to hold the electrode, what we want to do is we're actually going to drag the electrode along, and this is almost like rubbing your stomach and patting yourself on the head because there's so many things that you have to do simultaneously. One thing is you need to move, this electrode is going to start to melt and burn up. So you need to move your electrode down in order to keep the gap between your work and the electrode the same length. The other thing you need to do is move forward at a constant rate. Okay? And the third thing you need to do is you keep this at about a 15-degree angle forward. So 15 degrees from vertical. So right about there. Okay? All three of those things you have to do at the same time. What will happen when you're welding is you're going to try to keep a molten puddle and keep the metal dripping into that molten puddle. If at any time that molten puddle gets really large, you're going to end up burning through your workpiece. If at any time it gets really small and you jump ahead of it, you're going to have an area where there's no weld. Okay? It'll just look like you jumped and there's no metal right there. So at this point, I'm going to actually produce a weld, and we'll see how it goes. Strike the workpiece, longitudinal motion. Allow it to cool down. Notice that I didn't actually finish the bead all the way to the end. Also notice, I don't know if you noticed that I wasn't welding right on the edge. This material that we're welding is kind of thin. Put it up here, right? This material is kind of thin, so possibly you can melt through it very easily. So the first time you put a bead on here, if you put it right on the edge, you're going to melt the edge right off. Okay? It should probably be about a 1/16 of an inch thicker in order to not melt through it very easily. So it's going to be a little bit more sensitive. So at this point, what I would want to do is pick up the chipping hammer, which is also on your wall here, and pliers. And you really need to watch your eyes. Okay? A hot piece of slag can ruin your eye. So pick this up, chip away from you. Wire brush. Now, on your first pass, you might notice a little bit of an indentation on the surface. This indentation can be caused by two things. One is we're melting almost through the back side, which is the case here. The other one might be that your electrode might be too close to the workpiece. Okay? So this will be remedied when we actually put another pass over the top of the previous pass. We'll actually want to probably put several passes over top of this. And one thing, keep it straight in your mind. You don't have to go all the way to the other end of the workpiece. Wherever you end up, that's fine. Okay? So a lot of people, what they'll do is they'll race in order to try to get to the other end, and then they make their weld very thin. Okay? This plate's probably a little bit long. Comparing, this is what the plate should look like. Maybe not quite that thick, but after you completed it, it has some thickness. See, this is all weld bead that's been built up. Okay? The next pass I'm going to weld right next to the previous pass so that it overlaps the previous one. Okay, so the next pass I'm going to put right here. Okay? The other thing you're going to want to do is cool down your workpiece each time. This is very thin material, so you're going to want to take your pliers, take it over to the water bucket, and cool it down. Okay. Don't put your glove in the bucket. Not only does that make the leather hard, if you touch the workpiece and it's hot, you're going to steam your fingers like a lobster. Okay? So I'm going to take the cool workpiece back over here. We're going to put a pass right next to the previous one. Okay, remember what you're going to do is you're going to weld half on the previous bead. Okay, so half of your weld is going to overlap on the previous bead. And then you're going to hold it at about 15 degrees forward angle. Okay, perpendicular in this direction. Okay, and strike it, create an arc. You want the arc to be about 1/8 of an inch to 1/4 of an inch off the actual molten puddle. And remember that you want to create a puddle that's about 3/8 of an inch wide for the whole length of it. If you go faster, it'll get narrower. If you go slower, it'll get wider. Okay? So let's try it again. Okay, then we've done the second bead. You can see we overlapped the second and the first bead. I haven't chipped the slag off yet. I'll let it cool a little bit. Also be real careful of the electrode on where it is hanging on the wall here. If you touch that, especially if you have a bare hand, you're going to probably burn a hole or a small hole in the top of your skin. Okay? Remember, chip away from you. Okay. Well, it looks pretty good for the most part. You can see that there's like semicircular striations in the surface. That means you're traveling at a good speed. If you go too fast, those will look like arrows. They'll look like chevrons. Okay. If you go too slow, this will be a really big puddle. It'll probably burn a hole through your plate. So this is about what it should look like. Okay. If you get little inclusions like this, it's a small slag inclusion there. I went a little bit too fast right there, okay? So make sure you get all the slag out. If you have to, you can maybe grind that out. So when you put your next pass over this, you want to go all the way across this, and then maybe go over it one more time. They're not going to look this nice if you have never welded before, okay? They're going to start out looking a lot like bunches of slag in the surface. Look like little BBs on the metal, okay? You're going to have to practice in order to make them look like this. That means that you might have to come and get another plate after a while if you really screw this one up. But try as long as you can on one plate, because we don't want to go through too many of these plates. Okay?